Group differences and factorial design. We covered GLM 1 and 2, which entails 1A ANOVA and ANCOVA, 1A ANCOVA. That's what we learned. Now we are moving to factorial design 2A ANOVA. And a key term here before we get to SPSS is a factorial design. What does that factorial design? We learned that from first lecture about one way when we are learning the concept. There are two independent variables with different levels. So example, in this slide, you will see one independent variable, types of diet, A, B, C, 3 levels, and then education levels, which include 3, high school, college, and post-graduation. Combination of those independent variables levels creates 9 different sales factors. And that's why it's a factorial design. Going back to here, so factorial design, more than 2 creates different cells so that we can look at interaction effect between 2 independent variables. So going back to last week class, what does that interaction effect again? Let me start with the main effect. The main effect difference is diet differences only. And what is main effect of education? Education level differences on weight loss. That's an independent variable. That's a dependent variable here. Interaction effect, you're looking at differences between high school diet C versus diet A. College diet A, college level diet C. You could also look at college diet A versus postgraduate diet A. Do you see that combination? They're looking at it. That's called interaction effect. Okay. Then last one, post hoc again. Post hoc test. I'm going to go back to the previous slide, the week before this lesson. Post hoc differences will tell us differences between only main effect. Differences between diet types, 3 types. Differences between, among, more than 2. High school, the educational level differences. If we want to look at interaction effect differences, which means high school diet different, whether that group is different in terms of weight loss compared to high school diet C, or high school diet B to postgraduate diet B. And postdoc do not produce that output. So we have to learn one more step, which called simple effect test to look at cell differences within the factorial design. And this one, not gonna be, you won't be able to do this one by clicking. You have to use a syntax program. So I'm gonna show you how to do it when we get to the that analysis. Okay, so that's a concept. Now we are moving to the SPSS analysis. Okay, so SPSS step by step. First, we need to understand data. So data is actually, if you read very closely, it creates 3 by 2, or it can be 2 by 3, wherever you want to place which variable, it's different. So 2 by 3 factorial design with a total of 48 participants, and each cell has 8 participants. It's a pretty small sample size considering the research design. So what is that placebo, low dose, and then high dose? They want to check whether drinking, in other words, it's called beer goggle effect. So if you drink more alcohol, and then can you the way you looked at, perceive the physical attractiveness detoured or not. So what they did, each drinking, it's a cross-sectional, it's not repeated. each level placebo and the low dose and then high dose. And then after each drinking, each group drinking their fluid, they looked at 50 different attractive faces. Then they rated 0 to 10, 0 not attractive at all, 10 very attractive. They also looked at what? Unattractive, a 50 card of picture of unattractive faces, and then they also rated 0 to 10, 0 being not attractive at all, and 10 very attractive. And then they wanted to look at the differences between drinking level, no alcohol, low level of alcohol, and high level of alcohol. That's dosages, and two different face attractiveness on their attractiveness scale. Got it? So dependent variable is what? Attractiveness rating, right? Having that said, now let's move on to assumption test. The first, outliers, normality using explore by group. So this one doesn't have to be interaction, okay? Just to look at by the attractiveness group, two groups, two levels, and alcohol level, three levels. Okay. Then homogeneity over variance, it comes it out with ANOVA. So we'll do that through ANOVA analysis. And in terms of a normality, read very closely this statement here. If it violates slightly, ANOVA is robust enough to continue with slightly non-normal data. So that's what they're talking about. All right. Now, moving to SPSS here. There are total of a step 1 to 8, and 8 is the new one to you. And we learned 1 through 7 last time. So I'm going to go step by step and clicking the dialog so that you can create your syntax file. Then we will do number 8 after we go over the results of 1 through 7. Okay? All right. All right. SPSS here. Face type, two levels, attractive, unattractive. And then alcohol consumption, placebo, which is no alcohol, low dose, high dose. Then their ratings of attractiveness, which is a dependent variable. So go analyze. General linear model, univariate. I'm going to reset here. Move to independent variables to fixed factors, depending on your research questions and the application, how you plan your application. It could be moved down to random effect, median dependent variable to dependent variable. Okay, then go to the model. If you say full model, then it'll look at phase differences, alcohol differences, and interaction also by default. However, at times, why we set the model or build the model, because some researchers have a multiple dependent variables here. They don't want to look at all of them and all combination of them because it's so complex and it's unnecessary. So they could have looked, they could build their own model and customize it. I want to look at only phase differences first, only these interactions, only that interactions like that. Then you can build that in this section. Okay, so since we're going to look at the full factorial design, which means main differences of independent variables, main effect, and interaction of it, which is a full design, so we just continue. I'm going to do contrast here so that we can practice phase time, alcohol, consumption level, so 3 levels. Phase type, if there is a significant differences, we don't need a post hoc because it's only 2 levels. So as soon as you looked at there is a main effect on phase types, then you go straight to where? Descriptive statistics, and whichever is mean score is higher, then you can say which one is higher, which one is lower, using mean scores and standard deviation. However, alcohol levels, we have 3 levels, so we need to look at post hoc, which we can do contrast or post hoc. Okay, so I'm going to do here Post hoc test. Simple. I'm going to use a simple. And what does all this mean? So you know where you can find those meanings and purpose of using it, right? Simple, using first, which means we're using placeable group as what? Reference group to compare to the low dose group and high dose group. Then continue. Plot, face, I want to look that line. Alcohol, of course, I want to look at how they are different in the figure. I want to look at both combination of it. Then you move face type horizontal, separate line alcohol. You got it? Then you add them. Then do you see that? Created interaction figure. It'll come out. And for the vectorial design, line chart is much better to look at main effect differences and also interaction effect. So it's easier to look at the group difference, cell differences using line charts. So always use a line chart and include error bar, confidence interval 95, and continue. Now, post face type, we don't need it, like I said earlier when we are clicking contrast. Then alcohol, yes, we need to look at post hoc to see which alcohol group is different to which is only main effect we're looking at it right now. And I'm going to practice Bonferroni, which is very conservative method. You can go with the Tukey, all right? It's safe to go with the Tukey. And continue. And estimated marginal means we can ask all three of them to adjust its the confidence interval, and as soon as you click compare main effect, it'll generate pairwise the post hoc test, which we're not going to look at it because we have option of a contrast and the post hoc. Anyway, so I will go over that, and let me use a Bonferroni here and continue. In terms of a save, we don't have anything that we are going to play with. However, option, we want to get descriptive stats. We want to have estimate of effect size. In the lecture note, I clicked this one as an option, but you don't have to. So I'm not going to do it here. And continue. And then you paste it so that you can build again your syntax file. It's a good practice to build your syntax file all the time, all right? I'm going to say okay. Then all these results in an order is the same as our lecture slide. So I'm going to go over lecture slide with explanation. I actually did not include this to main effect in the lecture slide, but you can take a look at. There is a clear differences right here. Right? So I'm going to move a lecture slide to here. Here we go. So we did 1 through 7 and we haven't done 8 yet. I'll get to that soon. Okay. First output, descriptive stats. Then homogeneity is right after. That was not significant. So it is safe to read ANOVA table. Output. Here we go. Main effect, face type differences. There was significant differences. Alcohol, consumption level, and attractiveness scores, absolutely different. And we need a post hoc to determine which one is different from which. Then interaction effect came out. What? Significant. So that means we need to look at cell differences using simple effect, which we will do it later, okay? Shortly, very shortly. Here we go. Then this is a contrast output, and as you can see, contrast says level 1, level 2, level 3. It's a number 1 to 3 that we put in the data sheets. Then using the placebo versus low dose and high dose, when they looked at the level 1 and level 2, not significantly different, which means in terms of rating face attractiveness, level 1 placebo and the low dose are not different, but there is a difference between 3 to 1, which means high dose if you're drinking more and then not drinking at all, your attractiveness rating is different. Not by these two groups though, the attractiveness group, an attractive picture, unattractive picture. No, it's looking at the only what? These three differences, main effect. Because main effect also came out significant. Then moving down, um, post hoc Bonferroni, it also confirms that there is differences between which one? Placebo and high dose, with the mean score 1.44. So based on these results, we can say drinking more alcohol tend to rate any pictures attractive regardless type of a picture. Okay, so like attractive pictures or unattractive pictures. Estimated marginal means attractiveness of a face. Um, Estimated marginal means pairwise doesn't mean anything. We just look at mean differences, and then people attractive faces tended to be rated higher as attractive face compared to unattractive face, significantly different. Then that differences is significant. It's same as 1A ANOVA here. And the alcohol consumption, you can see again here, pairwise comparison different. But like I said earlier, we don't have to really read these comparisons because we have option of contrast and option of Bonferroni or Turkey option to do post hoc. One thing that I want you to look at is this. Estimated marginal means we requested interaction. Then look at this interaction. Do you see the interaction? No. It doesn't give us interaction. In fact, cell differences between it creates 2 by 3, it creates 6 different cells, and it doesn't give us whether which one is different from which among those cells, right? That's why we need to run simple effect using syntax programming, not dialogue. Dialogue is not available. So I'm going to open up my syntax here. I have 2 different syntax. I'll tell you why later. So first syntax, GLM attractiveness by face type space alcohol. Then what is it? Using estimated marginal means face type alcohol, we are directly asking to run the table to look at attractiveness, the cell differences, and then compare as a face. Like start with the face type. Then output is exactly, here, estimated marginal means. Then their estimate marginal mean, descriptive stats with confidence interval. Pairwise, now we read this one when we have interaction effect with a factorial design that you used. So when you look at placebo attractiveness, got it? Placebo attractiveness and unattractive faces differences. Placebo attractive, unattractive differences, which is flipped anyway. So just to look at only one of them. Low dose, attractive, unattractive, high dose, unattractive, attractive, not significantly different. So only there are 2 differences. If you want to look at face as the reference, then look at the alcohol differences. Then you use the other one, then run it. Then you will see output flipped. Unattractive, attractive, and the alcohol consumption level and differences. So if this is easier for you to interpret data, you can look at that way too. So you just change the order of the your independent variable. Okay, so putting that our lecture slide back here. So this is a figure that we generated as we are clicking line chart, and then you can see that attractive faces, unattractive face below, attractive faces red, and then their ratings are on y-axis. As you can see, there is interaction effect, and then high dose of drinking their attractiveness level. Doesn't matter whether it's attractive picture or not. It's pretty similar, and it came out in simple effect test, which is right here. There was no differences here. Do you see that? But these two differences came out not right in the picture. Significantly different, significantly different. Got it? Then, like I said, this is the first one we ran, simple effect, using placebo and the alcohol consumption level, goggle effect, as a reference. And in the other one, we used attractiveness as a reference and flip the results so that we can interpret it either way. How to report? A little bit complex, but you will need to start with, some researchers start with the interaction effect, but here, example, I studied with the main effect differences, phase type differences, and then alcohol consumption level differences. Then I move with that interaction effect right here. Then simple effect, the cell differences. And these are example based on our data that we just played with. So match those numbers and where I picked these numbers, all right? And then learn it from there and apply to your statistic number 10.